Welcome to today's chemistry lecture. In this lecture, we are going to start our new chapter, which is water. In this lecture, we will discuss the three main points: water, the essential necessity of water, the purity of water, and the difference between tap water and distilled water. So, without wasting any time, let's start our today's lecture. First of all, water and the chemical test for water. Importance of water. First is life support. Water is vital for all forms of life on earth. Every living organism contains a significant amount of water and relies on it daily to survive. Industrial and analytical applications. Identifying whether water is present helps determine the purity of substances and is essential for analyzing various chemicals reaction. It is highly crucial in the food and pharmaceutical industries where unwanted water can alter the product quality and impact safety. The chemical test for water. To definitely prove the presence of water even in a tiny amounts, we use a highly sensitive chemical test involving copper sulfate. First, hydrated copper sulfate. This salt naturally contains water molecules locked into its crystal structure, water of crystallization, and distinctly blue in color. Anhydrous copper sulfate. When the blue crystals are heated, they lose their water molecules and turn into white powder. The test: if you add a drop of liquid to this white anhydrous powder and it turns back to blue, it chemical confirms the presence of water. It's an irreversible reaction where first we will heat the copper sulfate to eliminate the water, and after that it colors will change blue to white. While adding the water, it will turn back into blue color. The purity of water. While the chemical test above tells us if water is present, it does not tell if the water is pure. To test the purity, we look at physical constants. First, physical constant of pure water. Under standard condition of temperature and pressure, pure water has a fixed physical properties, which means water exactly have boiling point of 100 Celsius or melting and freezing point exactly at 0 degree Celsius. The effect of impurities. If dissolved impurities are present in a water sample, they alter these physical constant in specific ways. How? Let's see. Boiling point elevation. Impurities cause the water to boil at higher temperature than 100 degrees Celsius. And the melting point depression means impurities cause the ice to begin melting at a lower temperature than 0 degrees Celsius. Importance is that these exact values means 100 degree and 0 degree change at high altitude or under or lower atmospheric pressures. These are the basic standard values in normal atmospheric pressure, but if we alter the environment or atmospheric pressure or lower or higher altitude, they will change naturally. Here comes our first quick check problem, which is how purity of water can be checked by determining its freezing point. As we studied previously, to check the impurity using freezing point, cool the water sample until it freezes completely. Then allow it to melt while recording the temperature. If the ice begins to melt at exactly 0 degree, it's a pure sample of water. If melting point is below the 0 degree, it proves the presence of dissolved impurities in the sample. Now we will see the difference between distilled water and tap water. First of all, we will see the tap water. Source: supplied to homes and office via infrastructure organizing from underground source or surface water like rivers, lakes and ponds. Composition: contains various dissolved minerals such as calcium and magnesium salts depending upon its region. It also contains chemical additives like chlorine and fluoride salt introduced during water treatment process. Electrical conductivity. Because it contains these free dissolved ions, tap water conduct electricity. pH range typically ranges between 6.5 and 8.5 depending upon its mineral source. Distilled water production formation, which involves heating water until it turns into steam, leaving impurities behind, and then condensing that steam back into a separate clean liquid container. This completely eliminates dissolved minerals, microorganisms, and contaminants. Composition consists only pure water molecule with no bacteria, ions, or gases. Electrical conductivity. It is a bad conductor of electricity because there is no free moving ion to carry an electric charge. pH. Distilled water had perfectly neutral with the pH of 7. Uses. Ideal of precise scientific laboratory experiments, pharmaceutical manufacturing, medical procedures, sterilizing equipment, and preventing scale corrosion. While safe to drink, it lacks the essential healthy minerals our bodies typically get from drinking water. Here comes our second quick check question. Why tap water is a conductor of electricity whereas the distilled water is not? Answer. Electrical conductivity in a liquid requires the presence of mobile charged particles, means ions. Tap water contains dissolved mineral and salts such as calcium and magnesium salts, which break apart into free moving ions, allowing an electrical current to pass through, while distilled water undergo distillation, which removes all the dissolved mineral and salts because it consists strictly of neutral water molecules and suffer from an absence of free ions. It cannot carry a charge and act as a poor conductor.